Let us introduce the scientific notation or the standard form. It's written as a times 10 to the power n. A is a number which is between 10 and 1. Okay, it can be an integer or a decimal. A is equal to 1 or greater than 1, and A is less than 10, which shall show using examples. So why do we need scientific notation? Look at these numbers. If they say add these numbers together, we cannot put this number here, then the other one there, then the other one there, trying to add them. That's going to take a lot of space, and even reading those numbers is going to be very tiresome. So that's why the scientific notation was introduced. So let us start with the very large numbers. Convert number 1 to scientific notation. So you need to make this a number between 1 and 10. So we need to move this comma from this position to this position. So your A will be 1.00. So we have moved the comma from this position to this position so that our A is a number equal to 1 or greater than 1 and less than 10. So this is fine. Times 10, what's the power here? From this position to this position, how many positions did you move? 1, 2. So this will be 10 to the power 2. Let's do the next one. This one should be between 1 and 10, so it will become 3,00. Now it's between 1 and 10 times 10 to the power. Your comma moved from this position to this position to make it a scientific notation. So how many places did it move? 1, 2. Let's do the next one. The comma moved from here to here to make this part of the scientific notation, remember, between 1 and 10. So we would say 9,2 is now between 1 and 10 times 10 to the power. The comma moved from here to here, it moved 1, 2 positions. Next one, we need to move the comma from here to here so that this is 1,0. It becomes part of A. So 1,0 or just 1 times 10 to the power. How many commas did it move from here to here? 1, 2, 3. Next, we need to make this 3,0 times 10 to the power. How many positions from here to here to make it a scientific notation? 1, 2, 3, 4. Next, to make this a scientific notation, we need to make this 9,2. You can write 9,276. 276. Now it's a decimal between 1 and 10. Multiply by 10 to the power. How many positions did it move from this point to this point? How many numbers are there? 1, 2, 3, 4, 5, 6, 7. From this point to this point, there are 7 numbers. So that was how you convert an ordinary number to scientific notation. Now let us do it in reverse. You are given 5. So we write our 5 down times 10 to the power 3. So from this position, 10 to the power 3 means it is a very large number. When you put a minus, it will be a very small number. So to make it a very large number, we need to add a lot of stuff this way, like it will look like this. So how many positions did it move from here to make it a large number? It moved 3 positions. So from here, position 1, position 2, position 3. So your answer is 5,000. Let's do the next one. This one, it has moved 2 positions to make it a large number. We had a 3,2. So to make it a large number, we need to move these 2 positions. That's position 1, position 2. So the comma will come here. So we are going to have 3, 2, 4, 6. it has moved 2 positions from here to here to make it a large number. Remember, when you're dealing with positive n, these are large numbers. When you be dealing with negative n, it will be very small numbers. So if you know that these are large numbers, you'll know how to increase this. So this is a positive number, so we need to increase this from 3,2. We need to move these 3 positions, 1, 2, 3. So our comma will come here. So this will be 3,246. Here we need to move it 4 positions, 1, 2, 3. We don't have another position, so this is 3, 2, 4, 6. We moved it from here, 1, 2, 3, 4. So our comma is moved from here to here, and there are 4 positions, 1, 2, 3, 4, according to this. Let's finish up. We have a 9,6, and to make it a large number, we need to make sure that we have 6 positions. Let's see from here, 1, 2, this is the comma position. So 1, 2, 3, 4, 5, 6. Our comma is now here. So this will be 1, 2, 3, 1, 2, 3. This will be 9.6 million. Let us deal with very small numbers. So when you're given numbers less than 1, let's say you are given decimals, you will be using a negative n. So let us show using examples. Convert 0.1. We need to move this 1 position this way so that this 1 will be able to fit into this condition. So this will be 1 times 10 to the power. How many positions did it move? It moved 1 position to get here. So to make a decimal into a scientific notation, you put a negative. So it moved 1 position. Let's do this one. This should be a 4. So for the comma to move from here to here, to make it a scientific notation, to read the 4, we moved 1, 2, 3. Okay, 1, 2, 3. Between this position and this position, there are 1, 2, 3 positions. So this is times 10 to the power minus 3. You always put a negative when you are dealing with decimals, like complete decimals, 0.000, not 1,2. When it's a decimal like this. So this one, to make it a scientific notation, we just need 5,6. So this will be 5,678 times 10 to the power. We moved to only 1 position between this comma point and this comma point. We moved only 1. Now this, to make it into a scientific notation, we need 9.4. Now it's in scientific notation times 10 to the power. From this point to this point, how many places are they? 1, 2, 3, 4, 5. Next, to make this into scientific notation, we need 2.1. 2.143. Now our A is good, times 10 to the power. Between this point and this comma, how many positions did you move? 1, 2, 3. Now let us convert this to ordinary form. Now remember, minus means it's a decimal. So we have our 5 and we have to put some zeros here. From this position, there was 3 decimal points, 1, 2, 3. Okay, the comma moved 3 points from here to here, 1, 2, 3. So this will be 0.005. Let's do the next one. We have a 5,4. Let's write it as 54. From this point, it moved 2 positions. From this, it moved 1, 2. And the comma came here, so it will be 0.054. Let's do the next one. It's a 6781. It moved 5 positions from this. So from here it moved 5. This is 1, 2, 3, 4, 5. The comma moved 5 positions or 5 points from here. So the comma moved from here to here. 1, 2, 3, 4, 5. So this would simplify to 0.1, 2, 3, 4, 5. Let us finish up with mixed examples. Convert to scientific notation. So this needs to be an 8 for it to be scientific notation. So you ignore this, then you deal with this. This will be 8 times 10. For it to be scientific notation, this comma should come here. Now, how many points from here to here? It's 1, 2. Saying this is a decimal. So this will be minus 2 times 10 to the power 5. So 0.08 is changed into this. Now, this will be 8 times, the bases are the same, so you add the powers. Minus 2 plus 5. And this will be an 8 times 10, 5 minus 2 times 10 to the power 3. So we've converted this to scientific notation. Let's do the other one. 200 should become 2.0 times 10 to the power. The comma was here. To make it scientific notation, the comma should come here. How many points from here to here? It's 1, 2. Now this is not decimal, so it's positive 2. Times 10 to the power minus 2. So this was our 200. So this will become 2 times 10 to the power 2 plus a minus 2. 2 plus a minus 2, that's a 0. So this is 2 times 10 to the power 0. Yes, 10 to the power 0 is 1. But you have to write it in scientific notation. And remember, in scientific notation, it's a times 10 to the power n. So you have to leave it like this. Convert to ordinary form. This one, we had 0.08, then times 10 to the power 5. The comma is moved 5 positions going this way to make this a very large number. Let me put just extra zeros. So let's move the comma this way to make it a large number. 1, 2, 3, 4, 5. So there should be 5 positions between the first position of the comma to the next. So this will be, we no longer need them, 8,000. That's the number in ordinary form. This one, we already had a 200. And the comma was here, 200.0. So we need to move it this way to make this a very small number, because the decimal will be a small number. So this comma should be moved this way 2 positions. So it will move from here to here, so that there will be 2 positions in between this position and the next position. So this will be a 2.0, or it's just a 2.